let's look at factoring polynomials. Now, this is a very big topic that will take more than one video to get through, so what we're going to look at right now is something called the GCF, which stands for greatest common factor, and we'll introduce the idea of factoring by grouping. Factoring is undoing multiplication in an expression. We look for numbers or variables that are common to each term of the expression and rewrite the expression with the common factor divided out of each term. Our result will look different, but will be equivalent to our original expression. Factoring out the GCF means to find the greatest common factor that divides all terms in the expression. Let's look at a few examples to see how we could do that. So we'll start with 5x minus 15. I notice that my two terms, 5x and 15, are both multiples of 5, so I immediately think let's take out a 5. I see the first term has an x, but the second term doesn't, so I know I can't take the x term out. So I'm going to take out the 5. And what I'm thinking about here is dividing. So if I think 5x divided by 5, it just leaves me with an x. And when I think 15 divided by 5, it gives me 3. So the next expression says 10y z squared plus 40yz. Let's start by talking about the coefficient. I have a 10 and a 40, and I think, well, 10 divides both. Then I see both terms have a y, and both terms have z. The first term has z squared, the second term has z, so I only take out the z. What you end up doing is taking out the highest power common to both, which ends up being the lowest power of a variable. So I say 10 divided by 10 gives me a 1, let's just write it. Y divided by y gives me a 1, and then z squared divided by z gives me a z. Let's go to the next term. I have 40 divided by 10, that gives me 4. Y divided by y gives me a 1, and z divided by z gives me a 1. Again, you don't have to write all of this, I just like to show you the first time we're going through what's happening. So how I would write this is 10yz times z plus 4. The 10yz, that is the GCF, so that was the greatest common factor. It shows the biggest term that's common to all the terms in the expression. The next example says 9xy cubed minus 15y squared. So I look at 9 and 15, and I'm trying to take out the GCF, and I think, well, they're both divisible by 3. The first term has an x, the second one doesn't, so I can't take out an x. And then I have y cubed and y squared, so I will take out y squared. Notice again, it's the highest power common to both, which happens to be the smallest power of y. 9 divided by 3 gives me 3. I still have the x. Y cubed divided by y squared is just y. Then I think 3 goes into 15 5 times. Y squared divided into y squared is 1, so I just have the 5. The next one says x to the fourth plus 9. The next one says x to the fourth plus 9x squared. So this time there's no coefficient that's common to both, but I can take out an x squared. It may help to think about the quotient rule for exponents as you're doing the factoring. Remember, you subtract exponents as you divide. So this term that was x to the fourth, I do 4 minus 2 gives me x squared. Then the 9x squared, the x squared comes out, and I just have 9 left. I can move this on to 3 terms and still try to look for the GCF as my start. With 8, 14, and 12, I think they're all even, so I know I can divide by 2. X cubed, x squared, and x all have an x, so I take an x out. This 1 is the smallest power, and it's as much as I can take out of all 3 terms. 8 divided by 2 is 4. Remember, we're subtracting this exponent. 3 minus 1 is 2. Plus 14 divided by 2 is 7. X squared divided by x is x. And then 12x divided by 2x gives me 6. The next example says 3x times x plus 2 minus 4 times x plus 2. I want you to see that this x plus 2 is common to both terms. So what do I do when things are common to both terms? I factor it out. Then I look at what's left. In the first term, I have 3x left. And in the second term, I have minus 4. The next one says 7xy plus 4y plus 21x plus 12. This is our start to factoring by grouping. Factoring by grouping says take the first two and take the second two terms and look at them individually. So 7xy plus 4y. I notice they both have a y. I take it out. I have 7x plus 4. The next two terms, 21x plus 12, are both divisible by 3, so I'm going to factor out a 3. 3 goes into 21 7 times. I still have an x. 3 goes into 12. I have 4. Now this looks like our previous example. I have this binomial, 7x plus 4, that's common to both terms. Because it's the same for both, I can take it out. Then I look at what's left. I have a y, and then I have plus 3. Let's try that one more time. This time I have x squared plus 8x minus 5x minus 40. It's important to note there is no GCF for x squared, 8x, 5x, and 40. They don't have anything in common. So in that case, I put the first two together, I put the second two together. X squared and 8x have an x in common, which leaves me with x plus 8. Negative 5x minus 40 have a negative 5 in common, so I'm going to take out a negative 5. Negative 5 into negative 5x is just x. Negative 40 divided by negative 5 is a positive 8. Again, I have this binomial that matches in both terms. I take that binomial out, x plus 8, and I look at what's left over, it's x minus 5. We will return to factoring by grouping in other videos. It'll help us in looking at trinomials with a leading coefficient not equal to 1, and it will help us as we look at special types of polynomials.